This Mathcast will walk you through section 11.3, where your students will use derivatives to analyze the shape of polar curves. Section 11.3 is a continuum of section 11.1 on polar area. In that section, your students use definite integrals to determine the area of regions contained by polar curves, while in this one, they will use derivatives to analyze the shape of polar curves. It is also a continuum of section 11.2, where your students learned how to find the arc length of parametrically defined curves. Now they will use the same strategy here to find the arc length of polar curves. Now both of these sections rely on a solid understanding of how to graph polar curves and how to convert a polar equation into parametric form or rectilinear form and then back again. Those were topics that were reviewed in Chapter 9. Lesson 11.3.1 starts with problem 11-76. In this problem, your students will convert the polar equation for the circle r equals 2 sine theta into its rectilinear form in order to implicitly solve for dy over dx and thereby evaluate the slope of the tangent lines to that circle at a variety of values of theta. Now, before we analyze a possible way to find the slope of tangent lines to a polar curve, problem 11-77 addresses a common misconception that students often make when dealing with polar curves. Namely, students often mistake the derivative dr over d theta with the slope of tangent lines. Now, Part B addresses this issue explicitly. It challenges teams to explain the difference between dr over d theta and dy over dx. This is a very important distinction for all students to make, so as you circulate, be sure to check in with every team and discuss how they answered Part B. And also plan a way to conduct a whole class summary of how teams answered Part B, perhaps with a math chat. That's where the study team strategy where prior to class you hang posters on separate walls. In this case, one poster will be labeled dy over dx and the other would be labeled dr over d theta. And then when a team is done with Part B and you discuss their answer with them, then hand that team a marker and send them on their way to the posters to write their thoughts about each term. And then they'll return to their seats to start the next problem with their team. And later in the period, after everyone has completed 11-77 and contributed to both posters, you can send teams one at a time on a gallery walk to read what other students were thinking about the topics. And the last, problem 11-78, will walk your students through how to use the parametric form of the spiral that they were shown in the previous problem to find dy over dx and use it to find the slope of tangent lines on that curve. Recall that derivatives of parametric equations were just introduced in the previous section, 11.2, so this lesson will be applying that skill in a new way. And then the final problem in this lesson allows teams to use the method of their choice to find an expression for the slope of each of these polar curves. Now, because the slope of some of these polar equations in this problem set can be found using more than one method, consider using a swap meet as teams get close to completing this problem. Swap meets are when you have a pair of students from each team take their papers and rotate to a neighboring team where they share their solution strategy and then report back to their original team what they learned. Lesson 11.3.2 starts with problem 11-90, where students review what they learned the previous day about finding the slope of polar curves. Since this is a review set, hot potato is a perfect strategy to use for problem 11-90. To do hot potato, each team should share just one sheet of paper, and each student should write with a different colored pencil or marker. The first student will start with Part A, doing the first step and explaining out loud what he or she is doing, and then pass the paper on to the next student who will use their own colored pen or pencil and either correct the work of the previous student, explaining their thinking out loud, or completing the next step out loud. And then they'll pass it to the next person, and that process will continue until all students in the team agree on all steps for all 4 problems in the set. The remaining problems in this lesson add a bit more context than the previous one. In problem 11-91, students generalize patterns about the slope of cardioids that differ by a constant, and in 11-92, they'll generalize patterns among the areas of the regions contained by the same family of cardioids. And problem 11-93 guides students towards recognizing that tangent lines along the same ray of a spiral will be parallel to one another, and so they can be shown to have the same slope. So this concludes our walkthrough of section 11.3, where your students learn techniques to find the slope of polar curves.